Hey guys, it's me Chiku from Chiku Study Corner. Today we'll be dealing with the chapter 1 of Chemistry Class 12 CBSE, that is solid states. So this is a new part, and if you haven't watched the previous parts, make sure you watch it and then continue watching. So, solid states. We discussed about what solid states is. We discussed about the classification of the solid states. We discussed about what is a unit cell, what is a crystal lattice, and now we'll move on to the classifications of unit cell. So the first classification, let's write unit cell. It's classified into two, that is primitive. The other one is non-primitive. Or centered. Okay, what is it? The two classifications are primitive and non-primitive. So under non-primitive, it's again divided into three. Okay, there is three classifications. That is body centered, face centered, and end centered. Okay, and under this it's just we have only to say one primitive category. So what is a primitive category? Let's take a cubic cell. Okay, I do a cubic unit cell. Now I'm telling you that there are molecules or atoms or ions in each of the corners. Okay, if your unit cell looks just like this is called as a primitive unit cell. Whereas for body center, let's draw a cubic unit cell first. This is the cubic unit cell. Then what happens? Here there is a atom, a molecule or ion, any of them. Yeah. Apart from this, what in the center of the cube there is one whole atom. Okay. So that will look like this. This is the cubic unit cell. Inside that, one atom in the middle. That is called as what? Body center unit cell. So to talk about face center, what do you mean by a face of a cube? That is each side of the cube. So each side of the cube has one each of atoms distributed. So how will it look like if this is the unit cell? How would that look like? Here there is an atom, here there is an atom, here there is an atom. So over here, this is the back face. I am drawing one on the back face and on the front face. And one on the bottom, one on the top. One from here, one from here. See, all is done. This might be a confusion, so let's avoid one opposite faces to make it more clear. So we are avoiding one face and just drawing it. Make sure you have the concept of face centered. What is it? All faces have one each. So how is that? Once more, let's draw. This is our cubic unit cell. And what are we doing? We are having opposite sides, and yeah, we've drawn on every opposite side except the front and the back. If you draw on the front and the back, there would be more confusions. That is why it is also there in the front as well as in the back. Okay, this is what is face centered. Now end centered. End centered is, let's take a cube. This is the cube. I'll draw it somewhere else. So end centered, I'm drawing it here. End centered. This is a cubic unit cell. End centered means if there is one atom over here, there is one atom over here. Okay, on the opposite ends of the cube there would be atoms. That is called as end centered cubic unit cell. So these are the classifications. Now we have to learn about a table which has all the 7 bravest lattices. All the 7 kinds of lattices based on the shape of the unit cell. We said that is cubic, there can be any other shape also. Okay, so let's learn. Now we are learning the new term. Now the topic that we are going to discuss is very important and this table has to be by hearted. Okay, and I will give you a small trick to by heart them. So let's see. The trick is CTOTHMT. Remember this. What is this? CTOTHMT. Please go in this order because I will give you a small trick to remember. Maybe it might be helpful for you. C is cubic, T is tetragonal, O is orthorhombic, T is trigonal, and H is hexagonal. And M is monoclinic. T is triclinic. Okay. Now what is this? Now we know what. We have to take 3 boxes. Okay. And this is the last box. So what is that? Now we'll write the angles and the edges. Okay. So angles. Look, we'll write the edges first. Okay. Edges. Then the angles. How do you define a unit cell? With A, B, C as the edges and angles to be what? Alpha, beta, gamma. So first one we'll write. A is equal to B is equal to C. Okay. What is that? Edge A is equal to edge B is equal to edge C. The second one for tetragonal, what would we do? We would cancel out 1. So A is equal to B is equal to C. That is, when you cancel out one of them, that should be like the one like this. A is equal to B, not equal to C. Okay, A is equal to B, not equal to C for tetragonal. And the next one is A is not equal to B is not equal to C. Okay, then what should you do? Repeat the same to the next 6. Okay, A is equal to B is equal to C. A is equal to B, not equal to C. A is not equal to B is not equal to C. Okay, and the last one is also A is not equal to B is not equal to C. Okay, now for the angles. For the angles, alpha is equal to beta is equal to gamma is equal to 90 degree. Okay, over here also alpha is equal to beta is equal to gamma is equal to 90 degree. Over here alpha is equal to beta is equal to gamma is equal to 90 degree. Okay, now over here what is that? Alpha is equal to, is not equal to beta is not equal to gamma. So now let me tell you one thing and then we'll finish these 3 columns. Okay, because over here it is not just like this, there is some differences. So let's write. See, now you can see A is equal to B is equal to C, alpha is equal to beta is equal to gamma is equal to 90 degree. And therefore what can you say? The cubic unit cell is the most symmetrical. Okay, watch. The most symmetrical. And which is the most unsymmetrical or which is the least symmetrical is called as the triclinic. Triclinic what? A is not equal to B is not equal to C. Alpha is not equal to beta is not equal to 90 degree. Okay. Now let's see what comes in between. So now let's discuss these special cases. So let's write this. What is over here? Alpha is equal to beta is equal to gamma is not equal to 90 degree. Okay. And over here what? Alpha is equal to beta is equal to what? 90 degree and what? Gamma is equal to 120 degree. And over here what is that? Alpha is equal to gamma is equal to 90 degree. Beta is not equal to 90 degree. So this is what is to learn about the edges and the angles. So just remember this whole table. Now we have to see what all kinds of variations when these angles, for example, let's take when there is different combinations of these angles and edges coming, they form different types of the classifications of unit cell. So let's see what all are. And when I'm telling you, there is 14 Bravest lattice. So what is the Bravest lattice? Bravest lattice is the combination or the different combination of these angles and edges, which gives rise to the different unit cells. So first one is over here for everything. So I told you there is 14 Bravest lattices. So there is 14 Bravest lattice. I'm just rubbing this. So let's write what are names of what all can be possible. So what is that? We are just saying what all are the possible structures or what all are the possible unit cells. Okay. So the possible unit cells. For every of them, primitive unit cell is possible. So what is that? Primitive. Everyone has primitive. So primitive, 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 primitive and primitive. So you can see there are 7 primitives already. So how many more are there? If there is 14 Bravest lattices and 7 are primitive, then how many more? There are 7 more. So according to this, what will be right? The cubic unit cell. Okay, the cubic unit cell can have face-centered, body-centered. Okay, and whereas for the next one, for the tetragonal one, what is happening? Face-centered is not possible, but primitive and body-centered is possible. Body-centered is possible. And for here, in this case, what is this? Primitive and end-centered. Okay? And rest all of them except monoclinic. Monoclinic also end-centered is possible. All the rest can have only what are primitive. See, now let's count. 1 face-centered. Now there's only 1 face-centered. Now what we are learning is that orthorhombic. Okay, the orthorhombic can have all of them. Okay, all of them. See, end-centered, BC and FC. Okay, body-centered, face-centered and end-centered is possible for orthorhombic. So what is that? Orthorhombic can have all the possible unit cell structures. So let's count. Primitive 1, 2, 3, 4, 5, 6, 7. 7 primitive done. Okay. And now let's count the face center. 1, 2. That's only 2. And body center 1, 2, 3. That is 3. 3 plus 2 is 5. And now what we have? End center 1, 2, 7. So 7 plus 7 is 14. We have 14 Bravest lattices that is possible. Did you get me? This is to talk about the whole box. I hope this is clear to you. What is that? First, how will you, if it is asked to do this column, then the 4th column would be this thing. I didn't have space, that is why I didn't draw the 4th column and do it. So the 4th column is what we have done, and the previous 2 columns are something that we have to do before writing this column. So the first one, what is that? Everything has primitive. So write primitive for everything first. And then what would you write? Then body-centered and face-centered for the first one. That is for cubic, there is body-centered and face-centered also. When it comes to tetragonal, what happens? There is no face-centered, only body-centered. Okay? And primitive is anyway there. Okay? The next one is orthorhombic. Orthorhombic has the capability of becoming everything and anything possible. So it has all of them. The primitive, the end-centered, the body-centered and the face-centered. Okay. And now the trigonal. Okay, the trigonal is having only primitive. They can only form primitive. Whereas for hexagonal, also they can only form primitive unit cells. But for monoclinic, what is that? There is end-centered also with the primitive. And for triclinic, also only primitive is possible. I hope this is clear to you. of atoms in a unit cell. So, we'll take simple cubic, then what? We have body-centered cubic, then face-centered cubic, and what? End-centered cubic. Am I right? So let's see. If these are all what we have to learn, let's count the atoms. What do we know? We know that what? Every edges have one atom each. Am I right? This is how a unit cell would look like. Okay. Now let's see. When the question comes, okay, number of atoms in a unit cell, you might think it's easy. So 1, 2, 3, 4, 5, 6, 7. 7 unit cells? Sorry, there should be 8, no? I forgot to mark 1. 1, 2, 3, 4, 5, 6, 7, 8. 8 unit cells. 8 atoms. But that is not the answer. So let's see how do you do that. First explanation is going to be with the primitive unit cell, a simple cubic unit cell. Okay, what is that? Simple cubic unit cell. So let's see. I am drawing a cubic unit cell. So now let's mark the points like this, okay? Okay. So what are we doing? I'm going to explain you how it is divided. So let's take a whole, let's take a Rubik's cube, and one of the middle portion or one of the middle cube has got a unit cell or an atom in the edge. Okay. So that single atom would be shared by how many more? See, there would be one in this side, one over here, and there would be like this, the same 4 in the back side also. Am I right? Yes. So what can we conclude? That is, one atom is shared by 8 unit cell, and therefore one unit cell gets how many of one atom? It gets only 1 by 8 of an atom. So let's see how is that. See, I am drawing the structure of how it will look like. Okay, I'll make it more clear. Okay, can you see that what only 1 by 8 of an atom is got by one of the edges of the unit cell, okay, or one whole unit cell gets only one atom from one side, 1 by 8 of an atom from one corner, okay. So how many corners does the cube have? How many corners? We have 8 corners. So what is in conclusion? We know that we will get what? 1 by 8 into 8. That is total of 1 atom. So what did we conclude? A total of 1 atom. What is that? First we thought how many atoms there is? 1, 2, 3, 4, 5, 6, 7, 8 atoms. But that is wrong. That is one end only gets 1 by 8, because why? There are more atoms in the surroundings which share that one atom. And therefore what? The number of atoms for a simple cubic unit cell is what? 1. Okay. Now we are taking the case of body centered. Okay. So body centered. For body centered, what is it different from our let's say our simple cubic? That is, one of an atom is completely inside the cubic cell. So what is the conclusion? The conclusion is that 1 by 8 into 8 was for what? Our simple cubic cell plus one whole cell or one whole atom. That is what? There are two atoms. The total number of atoms for a body centered cubic, a BCC, is what? 2. Now for face centered cubic. So for face centered also, what is that? You know there are 6 atoms on each of the faces. And when one, okay, let's say this is our what? Cube. And if there is one more cube coming to this side, if there is 2 cubes attached to each other, this is one face and this is the other face. When they come together, what? The one in this face is shared by this also. Therefore, what? The 6 atoms or 6, the 6 atoms on the faces would be shared by another one also. Therefore, what would we write? As usual, 1 by 8 into 8 plus what? 6 into 1 by 2. There are 6 atoms which are shared as half for each cell. So what would happen? Therefore, 1 plus 3, that is equal to 4. Now for end-centered. For end-centered, it's the same, no? That it's also in the faces and therefore it will be shared with another 2. And therefore for end-centered, what would happen? For end-centered, 1 by 8 into 8 plus 1 by 2 into 2. Okay? See, there's only 2. So 1 by 2 into 2. What is the answer for this? That is 1 plus 1. What is the answer? It also has only 2 atoms. 2 atoms. So let's just recap it once more. What was that? For simple cubic, how many was there? Only 1 was there, because each corner would have only 1 by 8 of an atom, and there are 8 such corners, and hence you have one whole atom for a single unit cell. And for a face centered, or let's say body centered. For body centered, what is the difference from the simple cubic? There is one whole of an atom immersed inside a cube, and therefore what is the number? That is 1 by 8 into 8 is anyway there, plus what? 1 atom. So that is 1 plus 1, 2 atoms. In the case of face centered, what is happening? There are 6 atoms in each of its faces. What? These atoms are shared only half. These 6 atoms are only shared by only 1 by 2 of the portion of that atom is gained by one unit cell. And therefore what happens? There is only 3 of them that is being shared. Okay, so what is that? 1 plus 3, that's equal to 4. And for end-centered, what is happening? There is only 2 in the faces. So half plus half is equal to 1, and there is what? 1 in all in 8 corners. That is 1 by 8 into 8 plus 1 by 2 into 2. So that is 2. That is all to discuss about what is the number of atoms in a unit cell. So now let's see what is the next topic. Next topic is called as packing efficiency. That is the percentage of space occupied by the constituent particles in the lattice. So let's see what's that. So packing efficiency. So I forgot to mention something. The number of atoms, we will represent this sentence, the number of atoms of a unit cell, as Z of the cell. Okay, Z. Okay. So because in this equation we have that. So what is packing efficiency? That is the space, okay, the percentage of space occupied by the constituent atoms in a lattice. Okay. So what is the equation? That is, we'll write packing efficiency as PE. PE is equal to volume of one atom into Z into 100 divided by total volume of the unit cell. So, volume of unit cell. This is the equation. So, what is that? Volume of one atom into Z into 100. If that is asked packing fraction, if there is packing efficiency, only you will write it into 100 because that is the percentage. And if it is asked for packing fraction, this 100 is not there. Okay, I hope this is clear. So let's find out, let me tell you, packing efficiency increases as the number of atoms increases. And therefore what? FCC has the maximum packing efficiency, whereas simple cubic has the least, packing efficiency. So we have to prove that. How will you prove that? Before that, we know if you taken a plot of 1 acre each. So there is 2 plots of 1 acre each. And if I am going to put something and I am going to fill it like this completely. Okay? And whereas in the case of the second land, I am just filling things in rows. Okay? What would be the packing efficiency of this? There is more of the stuff that is being put into. So there is more packing efficiency. Let's take a case of some kids having a school bag and having some balls. Due to the arrangement of some of them, some children can pack up to 10 balls, some can pack up to only 8, some can pack up to 5 or 2 or 3. That depends. And the most number of atoms that are being stuffed inside a bag would have the highest packing efficiency. That is the same case for our unit cells. So let's see. Now we have to prove what? We have to prove that our FCC has more packing efficiency than the simple cubic. So let's write. First one is our simple cubic. We'll start with simple cubic and then we'll continue doing it. Okay? So for simple cubic, I'm drawing 2 atoms. Okay? So, we know that this is a simple cubic. Here also there are atoms. I am just representing only these 2. And what is this? These 2 are touching each other and then hence let's take the length of this cube first. Okay, one side. That is A. We take one side to be A. And what is this? This is the radius of the our cube. Okay? Of our atom. So therefore what can we write? We should equate something. That is A is equal to 2R. So what is the equation for packing efficiency? I hope this figure is clear. So I'm just rubbing this and drawing it smaller. Okay. So this is our figure. Okay. There is one, there is another. Okay, this is the rough figure. Then over here, so what are we writing? Packing efficiency. That is volume of one atom. We are assuming atoms to be spherical. So what is the volume? 4 by 3 pi r square. Am I right? Into Z. Into Z. What is the number of atoms for simple cubic? There's only 1. And therefore 1. And should we write that? No. Let's leave that. Divided by what? Our volume of the whole unit cell. So what is the volume of the whole unit cell? That is A cube. Okay? A cube into 100. Into 100. So now we'll equate this We'll equate this equation to be 1 and we'll put this 1 in this equation. So what? We are adding this equation. So what would happen? Let's write 4 by 3 pi r square divided by what? It's A cube. What is A? 2r. 2r the whole cube. How will you write that? That is 4 by 3 pi r square divided by 8r cube. So, 4 by 3 pi r cube. How is it pi r square? Because that is volume. That is 4 by 3 pi r cube. And this is 8r cube. What would happen? These 2 would get cancelled out. Now, how will you solve this equation? That is, let's take packing efficiency. Packing efficiency is equal to 4 by 3 into 1 by 8. 1 by 8 into pi. Is this how it happens? So what happens? This is 1 and this is 2. What is this? This is pi by 6. And what is the value of pi by 6? What's the value of pi? Pi is 3.14 divided by 6. What would you get the answer? And we have 100 if that is what packing efficiency asked. We are writing packing efficiency. So into 100. If this was packing fraction, then this 100 would have like no role over here. So here also when you write the equation, write the 100 and do it. Or else you have to write packing fraction and do it, and then into 100 to find out the packing efficiency. So what is this? Into 100. Okay. So this is the packing efficiency. So you will solve this, and the answer that you will get is 52.4. So what is the packing efficiency for simple cubic? Packing efficiency for simple cubic is 52.4, and the rest, how much would be the rest? That is 48.6. The 48.6% is voids. Okay, this much is what the packing efficiency and this much is the voids. Okay, I hope this is clear. Now we are moving to the face-centered cubic. Okay, the next one is face-centered cubic. So, we'll draw the one face, okay? We'll draw one face and then we'll explain it. So, this is our unit cell, and what? We have a atom. This is the central atom and this is the other atom. So, what is that? This length is R plus R plus R plus R. Am I right? So what is this? This length is supposed to be what? It's supposed to be the hypotenuse. We know A. So let's find out the length first. So we all know, let's name this A, B, C, D. CB is equal to what? BD square plus CD square. That is A square plus A square. 2A square. That is what? Root 2A. Am I right? So what can you write? Root 2A is equal to 4R. R plus R plus R plus R. So 4R. This is the first equation. Okay? So we'll write this equation alone over here. What is that? We know root 2A is equal to what? 4R. Now let's write. So what is the equation for packing efficiency? That is the volume of one atom into Z into 100 divided by the volume of the cubic unit cell. Okay, let's write. What is the volume of one atom? 4 by 3 pi r cube. Am I right? Into, for face centered, what is the number of atoms? We said that is 3 plus 1, 4. Into 4 into 100 divided by what? R, like A cube, because that is the volume of the unit cell. A cube. So we know what is A cube. We have to derive A from this. So what is A? A is equal to 4 by root 2R. So when you write 4 by root 2R, how will you write that? 4 is equal to 2 into 2. Am I right? And 2 is equal to root 2 into root 2 into 2R divided by root 2. This is what is A. So you will cancel this, you will cancel this. So 2 root 2R is the answer for A. So what is that? A is equal to 2 root 2R. Okay? What is that? 2 root 2R. So let's write that over here. So we will substitute that. 2 root 2R the whole cube. Okay? So how will you write that? Let's write. That is 4 by 3 pi r cube into 4 into 100 divided by 2 cube is 8. 8 into what is root 2 cube? 2 root 2 into r cube. This r cube and this r cube get cancelled. This 2 and this would get cancelled, it will become 2, and this 8, this will become 1, and this is 2, this and this get cancelled. So what is our answer over here? What would you get? That is pi into 100 divided by root 2. Am I right? That is what? That is 3.14 divided by 1.14 into 100. So this is simple. You'll do the calculations and the answer that you will get is equal to, sorry, we made a mistake. What was that? We didn't consider this 3. This 3 should be also there. So this is pi by 3 root 2. Okay, this is pi by 3 root 2. So what is happening over here? I'll write it on the top because I think you cannot see the board. So you'll write, what is the value of pi? 3.14 divided by 3 into 1.4, that is the value of root 2, is equal to 74% approximately. And what is the remaining of that? 26% is what? Void. See, what did we find? The previous section, in the previous one, what was that? Our percentage was 52.4 and over here it's 74. You can clearly understand what this is more greater. But we'll go for body centered also. So that will be much helpful. So for body centered, we discussed so far. I hope it's clear to you. Now we'll do the body centered cubic unit cell. But the calculations are left to you as homework. So let's discuss about it and I'll give you a clear understanding. So this is a cubic unit cell. Okay? And here there is an atom, here there is an atom, here there is an atom. Okay? Like this. That is, I will show you. So let's take for example, this is a cube. It's a unit cell. Here we have an atom. Here also we have an atom. Okay? And let's take this stud. Can you see? And I'm keeping it inside this box. Okay? So this is going to be our atom in the middle. That is our body standard structure. So you can see this is the front one, this is the middle one, and this is the edge one. So this is like this. Okay? Like this. See? Like this. If you join, how will it join? Like this. Okay? That is what I've drawn over here. So this atom is in the back corner and this is in the front corner. Okay? And then when you draw a line, what is that? This R, R, R and R. Am I right? This is the hypotenuse to a triangle with one of its side like this. See. Now this is a right angle triangle. See. This is a right angle triangle. Am I right? This is the diagonal to the base face. Okay? So what is this? This is the diagonal to the base face. A side is A and therefore what is the diagonal of a square of side A? Root 2A. So what would be the, this hypotenuse? The hypotenuse would be root 2A the whole square plus A square the whole square. Okay? This is what? 2A square plus A square the whole square, that is 3A square root 3A. Am I right? Now let's write root 3A is equal to 4R. Therefore what? A is equal to 4R divided by root 3. Okay? So what is that? 4R divided by root 3. So we have to substitute and I will give you the final answer. You will go back home and do the calculation in the middle. So A is equal to 4R divided by root 3. Okay. So what is our equation for our packing efficiency? That is the volume of one atom into Z into 100 divided by the volume of the unit cell. So volume of one atom is 4 by 3 pi r cube into Z of a body centered cubic unit cell is 2 into 100 divided by what? That is A cube. A cube is 4R square R divided by root 3 the whole square. sorry, the whole cube, it's a cube. Okay, so the whole cube. So how will you write it? I'll just simplify this equation. When you simplify, what will it be? 64r cube divided by what? Root 3 cube is what? Root 3 into root 3 into root 3. That is 3 root 3. Okay. So what? 3 root 3. Okay. Now this would get cancelled. This would get cancelled. Okay. Now what do we have? Root 3 over here and 64r cube. R cube would get cancelled. R cube would get cancelled. Now you have to take a reciprocal. So 4 divided by 64 into root 3 and what? Root 3 into 2 into 100. Okay. So this is 8. This is 8 divided by 64. 8 divided by 64. So we'll rub this and we'll write what? 8 divided by 64 into what all do we have? Yeah, that is 5. Am I right? So what is this? 1, 8. So this is what our answer should be. You will do the calculation. It's simple. The answer, I'll write the answer. So the packing efficiency is equal to how much? That is 68%. What? 68%. That is there is how many percentage of void? 32% void and 68% packing efficiency. Okay, I hope this is clear to you. If you have any queries on this portion, please do give me a comment in the comment box below and I will be replying to your queries and doubts. So, if you have understood this video, please give my video a huge thumbs up and also subscribe to my channel if you are new to it. And share my videos with your other friends. So, see you on the next part of this chapter. Till then, bye.